Greetings! Now that my 10 gig system is pretty much all integrated into the enclosure of the dish, it's time to give it a try, all together integrated, including the TR sequencer. Obviously I've done some preliminary tests on the TR sequencer to make sure that things switched, and that's all working fine as far as the sequence goes, from receive to transmit, and so that's tackled already. I'm gonna spare you. So now I want to try the 10 gig transmit chain. So as you know, things don't start here. Things start at the IF radio. So I'm set to 144 megahertz. I'm in AM mode, so we'll be able to listen to that signal at 10 gigahertz. Okay, so I'll come back to that in a minute. And we'll also try Morse, so CW and sideband. Okay, on the radio I have my RF output at 144 megahertz. That's feeding into my input attenuator and transfer switch. Okay, and the other thing that I've done, completed, is the control cable here from the radio to the dish itself through this connector and then on to the TR sequencer here, and this is where detection of the radio is performed. This is where the transmit of the radio is inhibited until all the things are switched. And of course we have the push to talk, the PTT, that's sensed here as well, all through this cable. Okay, so IF radio is all hooked up to this thing. Now on the 10 gig side, I've disconnected the line going to the relay and on to the feed point. I've instead connected the coaxial cable here, and that coaxial cable is going into the spectrum analyzer through a 60 dB attenuator, 60 dB. So keep that in mind, that 1 watt will be 1 microwatt or minus 30 dBm into the spectrum analyzer. I have the spectrum analyzer centered on 10368. I'm actually centered on the output signal 10368, but I'm not in a frequency span mode. I've set the span to 0 Hertz, which puts the spectrum analyzer in a non-sweeping receiver. What you see from left to right quickly here, it's the signal as a function of time with 50 milliseconds of time lapse. You understand what I'm saying? It's not a frequency span from left to right, it's a time span like an oscilloscope, more or less. So we're going to see the output power as a function of time on the spectrum analyzer. And minus 30 is 1 watt. So if we go to minus 27 dBm, it's 2 watts, 3 dB more. Minus 24 is 4 watts. So somewhere between minus 27 and minus 24 is 3 watts. Now in order to listen to the signal, I've hooked up the IF out of my spectrum analyzer to an SDR dongle, a receiver, and the IF frequency is 3 megahertz, and I'll be listening to this 3 megahertz signal and assess the quality of the audio. I must tell you that I had to change the attenuation of inside this guy. I had initially designed it to 30 dB, but unfortunately it was not enough. Okay, why was it not enough? You'll see, it's a long story. This amplifier, the 10 gig amplifier, has a gain adjust potentiometer right here. But I just noticed when I initially tested the system and integrated into this system, not on the bench with its accompanying power supply, that the gain adjust did not work. It no longer worked in my system, and it did before with the Alcatel power supply. It happens that this brick also receives minus 12 volts from the Alcatel power supply that came with it. I decided not to supply that minus 12 volts because it's another negative voltage that's harder to produce. So I've decided to not use it. And it was also with the advice of the person who gave it to me. He said, I'm not even sure, I think it's for the protection, automatic protection system, that the -12 is used. Well, it's more than that. The -12 is also used to make this gain adjust work. So it clearly changes the bias on the amplifiers, maybe one of the stages, input stage maybe. So without the -12 fed to the amplifier, the brick is full on. There's no gain adjust, it's full gain out. So that's why I noticed that I had way too much gain, which means that in AM, when I was in AM, I had my full power out, and when I modulated, it sounded super distorted and there was no movement on the screen. Let me show you what a better AM, or I'll say a decent AM, acceptable AM is. And here it is. You can see there's some swing above and there's some swing below. There's more swing below than above. No wonder there may be some saturation on one of the two sides. Okay, so AM is not the best mode for this system because I'm not leaving quite enough headroom above as far as power for the modulation power to come out properly. But I don't intend to do any AM modulation on this system. So now let's look at the power we see. Notice the diamond on the screen in the center at the same height as the signal. Now you can see it. Okay, so it indicates the power. Look at on the left, we're at -29. Okay, which a little bit more than 1 watt unmodulated if I don't speak. So it means there's a little bit of headroom because you're gonna see when I go in Charlie Whiskey in CW, you'll see that there's more power coming out. Now let's listen to my modulation. So here I am about 3 inches away from the microphone. It is, as you can see, acceptable as far as the quality of the sound goes. It's not great by any measure, but I could certainly use AM, though it's not my main intent. Before I increased the attenuation into the IF attenuator, it was way too distorted. We could barely hear what was said. It was just saturated more or less. No headroom for modulation. So now it's better. Okay. Okay, and now if I switch to sideband, you can see that there's some headroom. It's only on the peaks that my audio goes above -30. So the peaks will be more than 1 watt. It'll be close to 2 watts, and that's exactly what I wanted. So judging by the quality of the audio, I think you can pretty much say that it's good enough. It sounds good enough on the audio front, on the quality, and I'm not saturating the amplifier, which was my requirement really. Okay, so as is, things are looking good. What could I have done differently? Well, I could have certainly inserted a pad, a 6 dB pad here on the input of the amplifier to reduce the drive. Instead of changing the IF signal power, I could have reduced the drive to the amplifier. What would have been the benefit? Well, right now, whatever the transverter is sending out, as far as spurs and the LO leak through, things like that, if I attenuate the IF signal into the transverter, it won't change these signals. These LO spurs will still show up regardless of the IF signal going in. As opposed to if I had attenuated the input of the amplifier, everything would come down. So the easy way was to reduce the IF signal, obviously. Because we work at 144 megahertz, 36 dB is the maximum of attenuation I can get with this box. Why so? Because the relay I'm using inside, it's just a standard switching relay, and this is pretty much what I get when the contacts are not closed at 144 megahertz, 37 dB. You know the pi attenuator that I have between these two ports? Well, I can even remove the connecting resistor in the middle and I'll still get 36 dB. So when I say I'm maxed out, that's it. I would have to think of using an RF relay instead of a regular relay to get more attenuation. But it happens to be good enough, 36, just enough for what I wanted to do. What could I do a little better even? I could try to reduce the drive. There may be an adjustment for the L1, the lowest setting on the radio. That's probably the easiest way to reduce the attenuation, and that's something I'm considering doing. It puts out 600 milliwatts. I checked it on 144, 600, and I would have preferred that it's more like 500. Maybe that's something that can be done. I'd have to look, to see what I do. So there are a lot of solutions to accomplish what I want to do. I went with the easy for me, just to change the IF attenuator, but I'm maxed out. If I need more attenuation, I could also add an attenuator in line with the IF signal, and the price to pay is that when I receive a signal, it will also get attenuated. But there's a lot of margin. The background noise produced by my transverter here on its output when we're in receive, going into the receiver, its background noise is pretty high. So I could waste 2-3 dB and I would still have more than enough sensitivity on this radio. It would still work. You see, there are several ways we could achieve what I want. But, those are the things that are on the table. For now, for first tests, it's good to go as is. I will disconnect my spectrum analyzer, reconnect my semi-rigid line, and I'm pretty much good to go for a first trial on transmit, actually transmit and receive, have a first QSO. All for now, there'll be more to come. 7-3.